All right, ladies and gentlemen, welcome to our continuation into our trigonometric functions. Today we're going to be looking at our very special angles. All right, so we're going to look at a little bit of geometry that you may have forgotten and really start diving into the trig functions. All right, so we're going to start off with what we call right triangle trigonometry. Most of this entire chapter, actually, believe this entire chapter is right triangle trigonometry, if I remember correctly. We will get outside of right triangles, but right now we have to start with basic definitions. So you see this right triangle in front of you. This angle theta is something we're going to be looking at again. And we're just going to name the sides of our right triangle. You could probably name those three sides A, B, and C, but we have special names for them. Obviously, this one is the hypotenuse, the longest side of the right triangle. It's always opposite the right angle. We're going to call this side the opposite side. It's opposite from theta, so it's across the angle or across the triangle from theta itself. And if this is the opposite side, the one closest to theta is called the adjacent. And if we would have moved the theta up to the top piece of this triangle, the top angle, then opposite would have been down at the bottom and adjacent would have been on the side. But we're going to look at this very specific one written this way. What we're going to do is we're going to define our trigonometric functions. All right, so our first one is sin theta. This is not sin, actually. This is sine S. Oops, be helpful if I did this correctly. And you obviously just saw the answer there. This is the sine, S-I-N-E, sine of theta. All right, so the sine of theta you might remember from geometry. You do a little bit of this in geometry. You even do a little bit in Algebra 1 and hopefully in Algebra 2. You might understand a little bit of this stuff here. So sine is defined as the length of the side opposite divided by the length of the hypotenuse. So sine is opposite over hypotenuse. All right. The next one is cos, and this is cosine of theta. And cosine of theta is the other sides here. This is the adjacent side divided by the hypotenuse. And then lastly, on this particular set, this is tan or tangent. Okay, this is tangent of theta. And tangent of theta is actually just what ends up being a ratio of sine and cosine. So it ends up being the opposite divided by the adjacent side. All right, something you may remember from geometry is this that I'm going to write up here at the top, SOH dash CAH dash TOA. And this is what we call SOHCAHTOA, because sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. It's just one of those little devices that help us remember what goes with what. Now, this is obviously something you should memorize, and most of you probably even have it memorized already. Now, here's the thing. That's not the only functions that we get to deal with. These are three basic trig functions. That's like what everything is based off of. And what we are going to then look at is what we call the reciprocal functions. All right, so the reciprocal functions are really the reciprocals of sine, cosine, and tangent. They get new names because we obviously can't use sine, cosine, and tangent. And we don't just say the reciprocal of. No, that'd be too easy. All right, so the first one is CSC. And this is cosecant. This is cosecant of theta. And cosecant of theta is the reciprocal of sine. So if cosecant is the reciprocal of sine, that means its ratio is the hypotenuse divided by the opposite side. All right, the next one is SEC. And SEC is secant of theta. And secant is the reciprocal of cosine. And if secant's the reciprocal of cosine, then we get the reciprocal of its other side. So this is hypotenuse over adjacent. And then the last one we have is COT. This is cotangent of theta. And obviously that means cotangent has to be the reciprocal of tangent. And we get the reciprocal of tangent being adjacent over opposite. All right, so these are our 6 trig functions that we deal with in this class. We will be looking at the inverses of these later, but right now these are the 6 trig functions that you are going to become very familiar with over the next 2 months, or a month and a half, I guess. It's so important that you can know that the cosecant's the reciprocal of sine, the secant's the reciprocal of cosine, the cotangent reciprocal of tangent. It just makes your life a lot easier if you make them known to you quicker. I'm going to put a little piece of information down here at the bottom. This being that sine theta is equal to 1 over cosecant theta. Or the other version of this being cosecant theta being 1 over sine theta. And this goes for the other 2 as well. If you want to write them, I'll go ahead and write what I can here. Cosine theta is equal to 1 over secant theta. So secant theta is equal to 1 over cosine theta. They are reciprocals of each other. It's like saying 2 is the reciprocal of the 1/2, and 1/2 is the reciprocal of 2. That sort of idea. Okay, and then the last one, let's go ahead and keep the color coordination going here. Tangent of theta is equal to, pay attention, 1 over cotangent theta, and cotangent theta is 1 over tangent theta. All right, a lot of little itty bitty things here that are going to just start piling up if you're not going to be focusing and paying attention on this stuff. This just being the beginning of it. All right, so let's move on to some special angles. And what we're going to be doing is we're going to be looking at our special right triangles, ones you actually learned in geometry. You may or may not remember them. Our 2 special right triangles are the 45, 45, 90 and the 30, 60, 90. And that's obviously the angle measures that we're looking at, and 90 being the right angle. That sort of idea, stuff we've dealt with before. All right, so what we're going to do first is we're going to start with the 45-degree angle. Now, let me tell you why we're doing this. We are going to try to know exactly what is the cosine of 45 degrees without a calculator. Because the more you can do without a calculator, the better you're going to be at this stuff. And these numbers don't come out nice, but they look nice if you don't deal with the decimal. And the calculator is only going to give you the decimal answer. And that's just not very happy. All right, so what we're going to do is we're going to start with the 45-degree angle, and because the math works in any lengths that we choose, let's just let the legs on this triangle both equal to 1, and the legs being the non-hypotenuse. All right, since this is a 45, 45, 90, it makes it isosceles, so technically this side is equal to this side. So let's make both of those lengths 1. And you can verify this for yourself if you want. If you make this 2 and this 2, everything still comes out the same. Now, if those 2 side lengths are 1, I hope you could figure out where I get this next number from. The hypotenuse of this right triangle is really, really simple to find. And I hope you're thinking to yourself Pythagorean theorem, because that's right, because it's a right triangle. A squared plus b squared equals c squared. And if you do all that math, you get a hypotenuse of length root 2. Now, you might remember these special ratios from geometry. I don't really care about them, because I can always recreate these triangles that I need. All right, so here I have a triangle now with 3 sides and an angle, which means now I can do all of those sine, cosine, tangents of the 45-degree angle. So if we just look first at the sine of 45 being the opposite side, so we're looking at 1 over the hypotenuse, so 1 over root 2. But we don't ever like to leave our answers with radicals in the denominator, so we multiply by root 2 over root 2, fancy form of 1, and we get a very simple answer of root 2 over 2. Guess what? I don't care what that decimal is, and I don't ever want to see the decimal of this number. I really like to see root 2 over 2, and so does the textbook, and so does SAT questions, and that sort of idea. All right, so let's do the same thing. Let's look at the cotangent, or not cotangent, the cosine of 45 degrees. All right, the cosine of 45 degrees is the adjacent divided by the hypotenuse. Well, that's the same thing as the sine, and that's actually okay. There's something we're going to point out here in a few minutes. And you get 1 over root 2, which simplifies to root 2 over 2. Then we can look at the tangent being the opposite over the adjacent, and opposite over adjacent in this case is 1. All right, so there's 2 ways to think about the next 3 here, the cosecant, the secant, and the cotangent. First is to just look at the triangle and go, okay, it's hypotenuse over opposite. Or you just think about, okay, cosecant is the reciprocal of sine. Now, this is the simplified version. You got to remember that the original version was, if I get my pen back here, the original version was 1 over radical 2, right? And then we simplified it to root 2 over 2. But the cosecant is the reciprocal of this fraction, so it actually just ends up being a root 2. And then obviously the same thing for secant. Secant is also root 2, and then cotangent is the reciprocal of tangent, and since tangent is 1, cotangent is 1. All right, so these are very important numbers, and honestly, it comes down to sine, cosine, tangent. If you can remember that the sine is root 2 over 2, cosine is root 2 over 2, and tangent is 1, you already know the other 3 because they're reciprocals. This trigonometric stuff is so, I'm going to use the word, it's so beautiful because you can just, if you know part of it, you know like the other half. And we'll get more familiar with that when we look at the unit circle. Some big thing that we're going to get to a little bit later. All right, the other one. So that was the 45, 45, 90. So we've just defined our sine, cosine, tangent of the 45 degree angle. So now let's do the same thing for the 30 and the 60 degrees. These are our special angles. When we get to what we call the unit circle, these 3 numbers, the 30, 45, and 60, those are going to be coming, they're just so huge in our study of trigonometry. Okay. So if we look at this, what we're going to do, you might remember this again from geometry. We start with a equilateral triangle. And if you remember equilateral, that means equiangular as well. So all 3 of my angles are 60 in this case. And what we're going to do is we're going to set each side equal to 2. You'll see why in a minute. All right, so set each side equal to 2. And then we're going to draw an altitude. Altitude being from one of the vertices to the midpoint of this. It ends up being midpoint, but to a right angle on the other side. So here's the one that I'm going to draw. And notice this cuts the angle in half because of some of our rules with equilateral triangles. So I get my 30, 60, 90 triangle. I get 2 of them, but I only really care about this one because I don't need to look at both of them. The length of the altitude, I hope you can use the Pythagorean theorem, but the thing is you don't want to use 2, 2, and 2 because this side length, the whole length is 2, the little length is only 1. And if you use the Pythagorean theorem, you get the square root of 3, and I'm going to swap out that 2 with some 1s in here. All right, so that shows us now a right triangle with side lengths of 1, 2, and root 3, easily found using Pythagorean theorem for this root 3. And now we can just go straight forward and do these calculations. Notice I'm giving myself a really big box or empty space over here. on the right-hand side, and that's because we got to do both angles. This one's for 30. So sine of 30, if you look at this 30-degree angle and you go to the opposite side divided by the hypotenuse, you get 1/2. If you continue this process, cosine of 30 is the adjacent side divided by the hypotenuse, and that is √3/2. Notice again, I'll keep saying this, I never show the decimals here. You should be able to do this without calculators. If I ever ask you, what's the cosine of 30? You should automatically be able to say √3/2. You should not have to grab your calculator to do it. And then tangent of 30 is opposite over adjacent, so it's 1/√3 that we then simplify to √3/3. Well, again, you can think about it one of two ways for the reciprocal functions. I know that cosecant is the reciprocal of sine, so I get 2. Secant's the reciprocal of cosine, so doing a little bit of manipulation, I get 2√3/3. And cotangent being the reciprocal of tangent, I get square root of 3. Likewise, maybe pause it for a second here and fill in this box before I fill in this box. So the sine of 60 is going to be opposite divided by hypotenuse. Well, the opposite of 60 is now √3, so I get √3/2. Cosine of 60, well, that's adjacent over hypotenuse, and I get 1/2. And you might be noticing something here that's going on. It's very important for us. Tangent of 60 being square root of 3. And then finding all of your reciprocals, but we already know all those reciprocals. We know that the reciprocal of √3/2 is 2√3/3. Secant is 2, and cotangent is √3/3. And there's little things that you need to notice here that are going to come up for us later. Notice that the sine of 30 degrees is equal to the cosine of 60 degrees. Well, that's pretty interesting. And then what you notice also is the cosine of 30 is equal to the sine of 60. It's also pretty interesting. One thing you're going to notice, though, 30 degrees and 60 degrees are called what type of angles? I hope every single one of you said complementary. Complementary means they sum up to 90. These two angles are complementary angles, and they have that very special property. Complementary angles have equal things here. So cosine of 30 and sine of 60, they're complementary angles. They have the same answer. All right, for sine and cosine. All right, so moving forward, a couple little things that we're going to be asking you to do in this particular lesson. We're going to let theta be an acute angle such that sine of theta, remember we're dealing with only acute angles right now. We'll get into the bigger angles later. We're saying that sine of theta is equal to 2/3, and you're going to need to evaluate the other 5 trigonometric functions of theta. Well, we just need to use what we know about sine. Sine is opposite over hypotenuse. So we can just draw a triangle, and you're going to get used to this in this particular chapter. You're going to be drawing lots of triangles. And we're going to put in the pieces that we know. I know the opposite side is 2 and the hypotenuse is 3. I can use some simple Pythagorean theorem and get the adjacent side to be √5. And now that I know those 3 sides of that right triangle, I simply just put in what I know. I already knew sine was 2/3. Cosine then becomes √5/3. Tangent was 2√5/5. Cosecant being the reciprocal of sine. Secant being the reciprocal of cosine. And cotangent being reciprocal of tangent. Right? Pretty straightforward. Some of these get a little bit harder later on, but right now everything should be straightforward as you go here. All right, another thing that we're going to do. This is one of the big things that we do with trig. Start off simple, get a little bit more challenging later on, but we're going to be solving right triangles. So you have a right triangle that has a hypotenuse of 9 that includes an angle of 38, and you need to solve for the missing parts of the triangle. So I'm going to put in what I know. Again, I drew a right triangle. I put in the fact that I knew one of the angles was 38, and I know the hypotenuse is 9, and we're going to use a little bit of simple math here. It's actually some simple trig. We're finally going to use some trig. So the missing angle, that's the easy one. Most of you could probably do this in your head. It's just 90 minus 38. It's whatever finishes out the 180 degrees for a triangle. So that gets to 52. Then we need to look at one of the two sides. It actually doesn't matter which one you choose. And notice I gave them some variable names, so x and y. This is what we can do. We can say the sine of 38 degrees is equal to x over 9. Well, since we're solving for x, I can just multiply by 9 on both sides. And if I multiply by 9, those 9s cancel. I get 9 sine 38. This is where you're going to need your calculator. And if you plug this into your calculator, you need to get 5.54. If you don't get 5.54, on the next page I'm going to tell you why, actually, and how to change your answer so you can get the right one. All right, if you get 5.54, you're good. You don't have to change your calculator at all, but you'll still need to know how to change it coming up. And then I can do the same thing for the other angle. Cosine of 38 is y over 9, so I can multiply by 9 on both sides. Technically, you can use quadratic or Pythagorean theorem, but since 5.54 is an estimate, I would tell you never to do that. All right, so times 9, and again, you should get an answer of 7.09. All right, so again, if you don't get this, it's because your calculator's in the wrong mode. Now, you do have a mode button on your calculator. I'm going to show you how to do that in just a second here. All right, so these are pretty simple problems. They're all doable for us. We can all do this. I know we can. All right, so if you did not get those two numbers on that last page, the biggest reason why is wrong mode. So because those are angles, and now we have two different, remember we have two different types of things now. We have angles we have degrees and radians. All right. In order to find the sine of 38 degrees, you need to be in degree mode. All right. So down here I have some instructions for the TI-83 and the TI-84. You hit the mode key and highlight the necessary mode. Next to, it says somewhere down there, degrees, radians. I forget the other ones off the top of my head. I guess I can look at mine. What do I have here? If I go to mode, you have, radians and degrees. That's it for that one. So if you're doing calculations with degrees, you need to be in degree mode. If you're doing calculations with radians, you need to be in radian mode. Those of you that don't have either of these two calculators, and you can't find it for yourself, just let me know. I will help you. I speak calculator. All right? If you don't know that about me yet, I speak calculator. That's why I know where all the parentheses go. All right? And I can usually figure it out, even if it's one I've never used before. All right? Other errors, the big thing, most of you have figured this out already. Errors come from using parentheses in the wrong spots. Okay? Make sure your parentheses are in the right spots and you get the right answer. All right, the last one right here. This one is huge, even though it technically shouldn't be. Well, I guess I can see why it is. All right, so cosecant, if you ever had to find the cosecant of 30 degrees, so if you wanted to go cosecant of 30, you already know 30, so 33 degrees, this is equal to 1 divided by sine of 33 degrees. Do not ever try to use this button on your calculator. We're using that later. This is actually the inverse button. This is sine inverse, not the reciprocal of sine. This is one of those areas, just like this. This was not the reciprocal of the function f. It was the inverse of f. All right, so it's the same kind of notation here. All right, so that finishes us off for today. You have your assignment sheet. Actually, some of you guys don't. Some of you guys do. Those of you guys in second period, you can get one from me tomorrow morning, Monday morning. Here's your assignment for section 2. And there will be a little mini quiz at the end of the day, the last 5 or 10 minutes or so. It'll just be a simple couple questions on this type of thing, possibly solving a triangle or two. But that being said, have fun with this. Trig's only going to get better, and some of you are thinking also that means it's only going to get harder. And so be it. It probably will. All right. Have a good evening. See you guys tomorrow morning.